Hi everyone, today we discuss oxidation, reduction, titration, what's mean by oxidation, reduction, and what's mean by oxidation, reduction, titration. Firstly, we have to define the oxidation, which have two definitions. All definition is combination of substance with oxygen. Here this substance combine react with oxygen. This is oxidation reaction. When substance react with oxygen to produce oxidized molecule or atoms, this is called oxidation. The current definition, loss of electron is oxidation. When the atom lost one electron or more, it become oxidized. So here, the sodium loss of one electron becomes sodium plus. This positive charge represent electron deficiency. One positive charge mean deficiency by one electron. Here, the sodium loss of one electron, so it's undergo oxidation reaction. What's mean by reduction? The old definition is removal of oxygen from the compound. Here this is substance, removal of oxygen of this substance by react with hydrogen. Here remove of oxygen, it's called reduction. Or gain of electron, it's also reduction. Here the chlorine gain of one electron become chloride, so this is reduction reaction. So here chlorine undergo reduction reaction. Negative charge represent electron rich, mean one negative charge mean rich by one electron. We would recall from you the earliest studies that your oxidation process result in loss of one or more electron by an atom. This oxidation process, loss of one or more electron by an atom. So here the ferrous are get oxidized to ferric by losing of electron from +2 to +3, gain more positive oxidation state. So it's lost electron to become oxidized to ferric. But here the chlorine, it's gain electron, gain of one or more electron by the atom or ions, it's called reduction. Here the chlorine gain electron to be reduced to chloride by gaining electron. This is reduction reaction. Oxidation or reduction are always fine together. If there is oxidation, there is a reduction. If there is a reduction, there is a oxidation. Because there is no free electron in the chemical equilibrium. There is no free electron. When there is substance loss of electron, must be there is other substance gains this electron. So such reaction are termed redox reaction, also or termed electron transfer reaction. Here the electron transfer from ferrous to cerium, because the ferrous loss of electron, so it's oxidized, and cerium gain of electron, so it reduced. Ferrous oxidized to ferric, and cerium +4 reduced to cerium +3 because it's gain electron and this loss of electron. Here the electron lost by ferrous are picked up by cerium, and so we can see there is no free electron in the reaction. Transfer of electron from one species of reactant to another in term change in the oxidation number. So the oxidation number of ferrous change from +2 to +3, so increase in the oxidation number, it's oxidation reaction. And cerium reduce oxidation number from +4 to +3 because it's gain electron, so reduce in the oxidation number. Okay, here we have to define the oxidizing agent and reducing agent. The species that have strong affinity for electron because it's gain electron because it's get reduced, but it cause oxidation to other substance react of them, so it's oxidizing agent. Repeat it again. A species possessing strong affinity for electron, so it has high affinity for electron, cause oxidation of other substance by abstracting electron from them. These species are called oxidizing agent. So, but these substances are themselves reduced because it's gain electron. Get it? Here, for the example above cerium act as oxidizing agent because it's take electron from ferrous, so the ferrous become oxidized, but itself it reduce. This cause oxidation of ferrous to ferric, so it's oxidizing agent. Reducing agent, opposite process. Reducing agent itself oxidize because it's high affinity to give up electron. It's give up electron, it oxidize, but this electron cause oxidation of other substance, so it itself oxidize, but it reducing agent. Okay, for example, the ferrous, because it give up electron to serum, so it reducing agent because it cause reduction of serum. Here we discuss different indications that use for oxidation reduction titration. Firstly, the self indication. The self indication mainly use potassium permanganate because have intense color. So if the titrant standard solution is highly colored, color can be used to endpoint without need for external indication. Okay, for example, 0.02 molar solution of potassium permanganate is deep purple. A dilute solution is pink. The product of its reduction, it's Mn+2, which is colorless. So when we have a sample, it's reducing agent, and the potassium permanganate, it's oxidizing agent. So potassium permanganate is reduced to Mn+2. So potassium permanganate react with the sample to produce Mn+2, which is colorless. So if there is sample here, potassium permanganate react with the sample to produce colorless solution. If the sample finish, so potassium permanganate remain as it and produce pink color, indicates the finish of analyte. So this is endpoint. So it's good detection self indication by potassium permanganate, and there is no need for external indication. Secondly, use starch indication, and this used mainly for titration using iodine as standard solution, because iodine form complex with starch to form dark blue color. The same thing if we use iodine as a standard solution. Sorry, let's continue. Here we use the starch indication for titrating using iodine. The starch form complex with iodine, so when we add iodine from burette to the sample, it's get reduced to iodide. When the sample finish, so there is excess of iodine, so this iodine react with starch, which was added as indicator to form dark blue color. The third type of indication using color dye, which are weak reducing or oxidizing agent and have different color in oxidizing state and reducing state. Have different color in oxidized state and different color in reduced state. This is redox indication. There are different type of indicator can be used for oxidation reduction titration. So for quantitative work, the standard solution or titrant must be stable during analysis. So when the titrant are reducing agent, can be susceptible to air oxidation to get oxidized. So most of redox titration carrying out using oxidizing agent as titrant. So in this case, the sample are reducing agent. So what the solution if the sample are oxidizing agent? We will note this later. So the standard solution mainly used is our oxidizing agent standard solution because it is stable during titration. If we use reducing agent standard solution, maybe get oxidation by air oxidation. There is several type of oxidizing agent as standard solution, and the choice of which of the several is which of them is best for particular analysis depend on ease of the reaction with analyte. If the analyte is a strong reducing agent, can be react successfully with weak oxidizing agent because the analyte are strong. If the analyte is weak reducing agent, the standard solution must be strong oxidizing agent, and so on. Okay, because if we have weak reducing agent sample and reacted with weak oxidizing agent standard solution, the reaction can be a slow reaction. The two most strong oxidizing agent used, permanganate and serum, and they have reaction. Potassium permanganate reduced to Mn+2 and serum reduced to Ce+3. Serum prepared from primary standard serum ammonium nitrate, so it's no need of standardization. It's highly pure. When it's prepared from grade reagent, serum oxide, the solution must be standardization with primary standard, such as ferrous. Ferronene is a suitable indication. Serum is available as primary standard, but it is not popular use because it's greater expensive compared with permanganate. We mainly in oxidation reduction use permanganate because it's available, cheap, and self-indication, but it have some problem in stability. Okay, are prepared from potassium permanganate. It's not available as primary standard, so need to be standardization, and it's thermodynamically unstable solution. Aqueous solution of permanganate unstable due to its ability to oxidize of water to produce MnO2. So this reaction can be catalyzed by the presence of MnO2, Mn+2, heat, light, acid, base. So we prepare moderately stable solution can be prepared by boiling the aqueous solution of permanganate for an hour and filter through center's glass filter to remove any solid. Then this solution can be stable for 1 to 2 weeks, and also standardization must be rechecked periodically to know the exact concentration of this solution. Another oxidizing standard solution is potassium dichromate. It's relatively a strong oxidizing agent. It is not as strong as potassium permanganate and serum. The principal advantage is availability as a primary standard and long-term stability to compare with potassium permanganate. But however, it is not as strong as serum and permanganate, so it's mainly used for titrating the strong reducing agent. Prevent its application to analyze that are weak reducing agent. These have reaction, although chromate have different color in the oxidizing form and reducing form, but this color is not intended to serve as a self indication. Analysis using iodine. Also, iodine is oxidizing agent, can be used divided into iodometric and iodometric. Iodometric subdivided to two: direct titration with iodine, reducing agent with oxidizing agent, or residual titration method by adding excess of iodine and remaining unreacting iodine react with sodium thiosulfate, or iodometric titration release of iodine and subsequent titrated with sodium thiosulfate. We will discuss this two assay in more detail in the next lesson lecture.